students, this is the 11 chemistry. We will discuss the strain 2, that is meta, and the substrain that we will look today is substrain 2.1, that is atomic structure and bonding. Let's look at the objectives of this lesson. You will define elements, atoms, and learn the first 20 elements of the periodic table. Then you will draw an atomic structure. Thirdly, you will calculate relative atomic mass. Then you will describe the valence electrons and electronic configuration. And lastly, you will define isotopes and learn its properties. Now let's recap from what you learned in year 10 during basic science. You must have learned about protons, neutrons, electrons, how to calculate the number of neutrons, and you also learned how to draw the electronic configuration of certain elements. Now we'll begin our class. Let's look at some of the definitions. The first one is elements. Elements are pure chemicals that are made up of only one kind of atom. That means there are no other combinations of any other chemicals in it. For examples of elements are sodium, potassium, calcium, copper, iron, sulfur, and magnesium. Atoms, these are the smallest unit of an element. Now we will learn how to draw the atomic structure. So this is your atomic structure of an atom. In the middle, this is known as nucleus. You will find protons and neutrons. So remember, protons and neutrons are found in the nucleus. And this is your energy level. In your energy level, you will find your electrons. Remember, protons are positively charged, neutrons do not have any charge, and electrons are negatively charged particles. These are three subatomic constituents of an atom. Then we'll look at the first 20 elements of the periodic table. Remember, you should know the elements from helium to calcium. These are the first 20 elements into the periodic table, and some of the elements that are found in between helium to calcium are sulfur, magnesium, iron, chlorine, silicon, boron, beryllium, and so on. So when you will refer to your textbook, you will learn the first 20 elements of the periodic table. Thirdly, you will learn how to calculate the relative atomic mass. Remember, relative atomic mass can be calculated using two isotopic occurrence of a same atom. So here I have taken chlorine 17. Both are chlorine 17. It has same atomic number as 17, but it has different mass number. That means the relative atomic mass of both of these is different. And here is the percentage abundance of these two isotopes. Chlorine 35 has 75.77 abundance, and chlorine 36 has 24.34 abundance. So in order to calculate the relative atomic mass of chlorine, you will use this formula: percentage abundance divided by 100 times mass of chlorine 35. You will add that to percentage abundance divided by 100 times mass of chlorine 37. So the percentage abundance of chlorine 35 is 75.77. So you will insert that into this formula, and you will divide that by 100 times the mass number. You will add that to percentage abundance of chlorine 37, that is 24.34 divided by 100 times 36.34, that is close to 37. When you will do your calculation, you will get 26.50 plus 8.95. Therefore, your relative atomic mass of chlorine is 35.45 atomic mass unit. This AMU stands for atomic mass unit. Now I will show you a video of how to calculate the relative atomic mass. So this is the video of calculating relative atomic mass.
Isotopic abundances. If we consider carbon, its relative atomic mass is very close to 12 atomic mass units. This is because in nature, 99 atoms out of 100 atoms of a carbon sample are carbon-12 isotopes. Another way of saying this is that carbon-12 has a 99% isotopic abundance. However, not all relative atomic masses of elements are weighted in this way. Chlorine, for instance, exists as two isotopes, chlorine-35 and chlorine-37. How many protons and neutrons do you think each chlorine isotope has? Remember, the mass number for an isotope is equal to the number of protons it has plus the number of neutrons. Pause and select from one of the following options. Use the chemical symbols to help you work this out. Both chlorine-35 and chlorine-37 have 17 protons, but the chlorine-35 isotope has 18 neutrons, whereas the chlorine-37 isotope has 20 neutrons. The answer was A. Did you get it right? In nature, out of 100 atoms of chlorine sample, 75 of those atoms are chlorine-35 isotopes, and 25 of those atoms are chlorine-37 isotopes. For you to be able to work out the relative atomic mass for chlorine, you have to multiply the mass number of the isotopes with its abundance, percentage, and add these products together. This gives the total mass number of the isotopes. Using this data, can you calculate the total mass of chlorine isotopes using their abundance and mass numbers? Pause, think, choose, and continue when you're ready. The answer is B. You have to multiply a 75% abundance of the chlorine-35 isotope by its mass number 35. You then have to multiply a 25% abundance of the chlorine isotope by its mass number 37. When added together, this gives a total of 3,550. The final step in calculating the relative atomic mass is to divide your answer by 100. This is because the abundances are given as percentages. This means chlorine has a relative atomic mass of 35.5. Here's a challenge. From the following data, calculate the relative atomic mass of uranium. Pause and continue when ready.
So that was a video describing the calculation for calculating the relative atomic mass of chlorine. Now we will go on to our fourth objective, that is describing valence electrons and writing electronic configurations. So I will elaborate on that using this model that I have made for you. So in the middle you can see the nucleus here, and the nucleus is composed of neutrons and protons. Then there are different energy levels, and these energy levels have electrons in it. Electrons have negative charge. Then the last energy level, it is known as the valence energy shell, or it will have valence electrons. Valence electrons, they are found in the outermost shell of any atom. I hope you have understood that. After that, you will learn how to calculate the electronic configuration. So in order to write the electronic configuration of any element, first you have to know the atomic number of that atom. Here I have taken sodium as an example. So this letter Z, capital Z, it denotes atomic number, and this capital A, it denotes the mass number. Atomic number is always equal to the number of protons, that is equal to the number of electrons. However, the mass number, it is the total of the atomic number and the number of neutrons. In order to write the electron configuration of sodium, we will use the atomic number. Since the atomic number is 11, we will use the formula that is here. Remember, according to Aufbau principle, it says the first energy level can occupy 2 electrons. That means the first shell, it will only consist of 2 electrons. Then the second shell, it can occupy 8 electrons. Third shell can also occupy 8 electrons. And the fourth shell can occupy up to 18 electrons. So it always depends on the atomic number of that element that will then consider the electron configuration. So now let's write the electronic configuration of sodium. So first shell will have 2 electrons. So here you can see 2 electrons in the first energy level. The second shell can occupy 8 electrons. So I have drawn 8 electrons here. And the last one, it will have only 1. Why? Because 2 plus 8 is equal to 10. And here you have 11. So 11 minus 10 will give you 1. So this is the valence electron of sodium. Then we will define isotopes and its properties. Remember, we said earlier that isotopes are elements with the same atomic number but different mass number. For example, this example that I have used to calculate the relative atomic mass, these are 2 isotopes of chlorine. It has the same atomic number, but the mass number here is different. The atomic number for both chlorine is 17, but the mass number, one has 34.97, that is equal to 35, and the other one has 36.97, that is close to 37. So these are isotopes. Now we will move on to the activity questions. I'll give you 5 minutes to complete your activity, then we will discuss it together.